over here, and this is a 2005 AIME 1 problem 8. Let's have a view of this problem. The equation 2 to the 333x minus 2 plus 2 to the 111x plus 2 is equal to 2 to 222x plus 1 has three real roots. Okay? Given that their sum is m over n, we want to find m plus n, where m and n are simply relatively prime. So they want to ensure that we have the fraction in simplest form. Okay, so let's just apply exponent properties over here. So this gives us, rewriting, gives us 1/4 2 to 333x plus 4 2 raised to power 111x. Extend that 4 a little bit, and then is equal to, this is 2 times 2 raised to power 222x plus 1. Great. So now let's actually do a substitution. Since every single exponent is a multiple of 111x, let's just simply let 2 raised to power 111x equal u. So now we can express this easily as 1/4 u cubed, 1/4 u cubed plus 4u is equal to 2u squared plus 1. Looks good. And then we don't like fractions, we'll multiply by 4 to get u cubed plus 16u is equal to 8u squared plus 4. Bringing everything over to one side gives us u cubed minus 8u squared plus 16u minus 4 is equal to 0. That's great. Now we want to find the sum of, has three real roots, so we want to find the sum of the x's that gives us the three real roots, right? So now we've noticed our substitution is this thing. One second, what? Okay, still works here. So we notice this 2 to 111x is equal to u. So if we let x1, x2, x3 be the distinct x's that make these the roots, we can actually note by the sum of the roots 2 to 111x1 plus 2 to the 111x2 plus 2 to the 111x3 for not necessarily distinct x1, x2, x3 is equal to 8. But now it's not easy to extrapolate what the values of x1, x2, and x3 have. Furthermore, even their sum, right? Because there's no need exponent tricks for the addition of exponents. So we can actually resort to maybe the product of the roots, because if we know we had the product of the roots, we can simply add the exponents, right? So let's do that. By Vieta, the product of the roots is going to be 4, right? So we have 2 to the 111x1, 2 to the 111th x2, 2 to the 111th x3 is equal to 4. Exponent rules gives us 2 raised to power 111, factoring out the 111 gives us, and then x1, x2, x3. Perfect, this is equal to 4. Now we can take log base 2 of both sides, but it's pretty obvious that this has to be 111 times x1 plus x2 plus 3 has to be 4. Therefore, this has to be 2 over 111. The sum is 2 over 111. These do satisfy the condition that they're relatively prime, so we add to get 113, and we are done.